we are given triangle ABC and we're asked to find a few different trig ratios. So sine of A, so here's my angle A, and I need opposite over hypotenuse. Opposite of A is my lowercase a, and the hypotenuse, that is always the leg that is across from the right angle, is C. Cosine of B, so now we're looking at angle B, is going to be adjacent over hypotenuse. So adjacent is A, and the hypotenuse is still C. So A over C. And notice how these ratios are the same? That's because sine and cosine are co-functions of each other. And now let's take a look at tangent of B. So here's angle B. I need opposite over adjacent. Opposite is B, adjacent is A. B over A. And now let's do the reciprocal trig functions. So cosecant of B. Well, cosecant is the reciprocal of sine, so that means cosecant is going to be hypotenuse over opposite. So hypotenuse is C, opposite is B. Secant of A, that's going to be hypotenuse over adjacent. So here's A, hypotenuse is C, adjacent is B. And again, you can see that co-function relationship here. And cotangent of A. Cotangent of A is going to be adjacent over opposite. So here's A, adjacent is B, opposite is A. And now number 2, find the 6 trig ratios. Sine of B equals 5 over 13. Well, sine is opposite over hypotenuse. So here's B, opposite is 5, and hypotenuse is 13. So if I want to find, say, cosine, tangent, those require the adjacent leg, and I don't know that one. So let's use the Pythagorean theorem to determine what this measurement is. So Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So that's 5 squared. We'll call this A. A squared equals 13 squared. So that's 25 plus A squared equals 169. I'm going to subtract 25 from both sides. A squared equals 144. And then if I take the square root of both sides, and I'm looking for the principal square root, only the positive because we're talking distance, A equals 12. So this measurement is 12. Let's just do a few. I don't think we need to do all of them. So let's go sine of theta. So theta was B, excuse me. We already got sine of B. Let's do cosine. Cosine of B is adjacent, which is 12, over the hypotenuse, which is 13. So 12 thirteenths. Tangent of B is opposite over adjacent, opposite adjacent, 5 over 12. Let's do cosecant of B. Well, cosecant is the reciprocal of sine, so that's going to be 13/5. And let's just do them all. Let's do it. Secant of B, that's hypotenuse over adjacent, hypotenuse, adjacent, 13/12, and then cotangent. Cotangent is adjacent over opposite. Adjacent is 12, opposite is 5. And now number 3, what is the value of x? So let's take a look at what I have. You need to determine, do you have opposite, adjacent, hypotenuse? Which two are we looking at? So here's my angle, 65 degrees. This 15, this relates to the hypotenuse. It's across from the right angle. My x, this would be adjacent. Remember, the adjacent leg and the hypotenuse form the angle that you're looking at. So then I have to think to myself, okay, so what trig ratio uses adjacent and hypotenuse? And that would be cosine. So that means I have cosine of 65 degrees equals adjacent, which is x, over hypotenuse, which is 15. And then I want to solve for x. So that fraction bar is division, which means we're dividing by 15. The opposite of division is multiplication. So let's multiply both sides. We're going to be left with 15 cosine of 65 degrees equals x. And at this point, you just grab a calculator and you pop it in. And depending on what calculator you have, depends on how you're going to enter it in. Mine, I can go left to right. Cosine 65. We're going to call that 6.3. We'll round it to the nearest tenth. And last thing out of topic 7.1, we're going to rewrite cotangent of 25 degrees in terms of its cofunction. So remember those cofunctions and think of that word co. You have sine and cosine are cofunctions, secant, cosecant, tangent, cotangent. And those cofunctions also have that complementary angle relationship. So if I'm looking at cotangent of 25 degrees, the cofunction for cotangent is tangent. And then I'm looking for that complementary angle, so I take 90 degrees minus 25 degrees, which gets me tangent of 65 degrees. And so that means cotangent of 25 degrees equals tangent of 65 degrees. And let's tackle 2 out of 7.2. I'm going to do positive angles. We did negative angles yesterday. So determine the angle measure. So if I'm looking here, remember positive angles move counterclockwise. So here I'm at 0 degrees. Here I'd be at 180 degrees. Well, I didn't quite go all the way to 180 degrees. I'd have to go back 50 degrees to get to the terminal side of my angle. So that means I'm going to take 180 degrees minus 50 degrees equals 130 degrees. If I look at angle or number B, letter B here, now here I'm into quadrant 3. So I've gone past 180 degrees. So I'm going to have 180 degrees plus 20 degrees equals 200 degrees.